everyone. We've got a great conversation here with Sachin Katti, Telco Strategy Advisor with VMware, and we're going to explore this journey towards network autonomy using artificial intelligence and machine learning. So, Sachin, maybe we can start big picture here, then get a little bit more specific as we go. But if you look across the operator landscape today, how would you characterize the state of network automation in terms of what particular processes and parts of the network are we seeing the most traction?
Yes, Sean, great to be here. So I think to set the context and set the stage, I think we are still in very early days in terms of network automation. If I zoom out and look at what's going on, I think, for example, there's quite a bit of progress made over the last few years in things like building out telco cloud infrastructure, right? So just laying out a cloud infrastructure on top of which you can potentially deploy virtual network functions. Obviously, over the years, vertically integrated solutions have made good progress in bringing up new hardware. For example, if you go put up a radio on a cell tower, it's pretty well automated that the radio can call home and configure itself and set itself up. So, but however, I think all things considered, still very, very early days in the network automation journey.
We've had a lot of conversations throughout the day around various aspects of OpenRAN, and I know this is something that you all are working on at VMware with Intel using their FlexRAN reference architecture and your RAN intelligent controller to sort of look at adding autonomy to that RAN optimization process through a closed loop analytical system where you apply some ML algorithms. Maybe you can tell us a little bit what you're seeing out of that collaboration and what that ability to conduct optimization autonomously in the RAN will really mean for operators and their businesses as it's matured and then scaled from pilot across networks.
Yeah, no, great question. So let me start by just expanding on what we are doing with Intel, and then I'll definitely answer what you were asking. So with Intel, we are working on making sure that vRAN workloads, so when you're virtualizing the radio access network and running it on top of a telco cloud infrastructure, that vRAN workload can work very well, highly efficiently, and in an automated fashion on top of a VMware Telco Cloud running on top of Intel Silicon, right? And FlexRAN has been kind of the mothership out of which a lot of virtual RAN solutions have been born. It's a reference stack designed for layer one. So we've been working closely with Intel and making sure that FlexRAN-based solutions for vRAN work very well on top of a VMware Telco Cloud. And part of that collaboration has been adding interfaces to support the RAN intelligent controller, which is basically one way to think about it is it's an SDN controller, but for the radio access network. So SDN gave you programmability of the wired network. The RIC is trying to give you programmability of the radio access network. And this really allows you to control what is happening to a traffic of a single user at very fine timescales. So literally your device, Sean's device could be connected to the 5G base station. We want to treat Sean's traffic differently because Sean right now is on a Zoom call. He's doing a live interview, and we need to make sure that that traffic is treated differently, scheduled differently, has a much higher level of reliability. So being able to kind of program the behavior of the underlying infrastructure at a per user level at very fine timescales is the kind of capability that the RIC enables. So you can now kind of let your imagination run wild with what you can potentially do with something like this, right? So historically, things like radio optimization and other technologies have been embedded inside the base station. And this is something that the operator could not tune for their own specific needs, or it was not easy to introduce new services. For example, I want to do business grade data, and that should be different from consumer grade data. So the RIC is basically going to give people the ability to introduce such optimization capabilities as quote unquote X apps on top of a RAN controller and add these in a modular fashion. So I think this is going to bring a lot of innovation and agility to the radio access network. It's really going to enable both operators as well as newer entrants to introduce new focused technologies that make the RAN perform much more efficiently, add things like differentiated user experience. Last but not least, it also adds automation, right? So a lot of the things that you have to do to kind of set the service up in the right manner, make sure that the underlying infrastructure is configured appropriately for the deployment environment you're in. So whether it's indoor or outdoors, for example, or whether you're in a moving scenario versus a non-moving scenario, or what frequencies you're using, how it should coordinate interference. All of those things can now be programmed as applications on top of this RAN controller. So tremendous potential here for both optimizing as well as automating the network infrastructure.
We've got an interesting question, Sachin, that's come across here that I think you can maybe address for us. But when we think of RAN optimization and applying autonomy to that, is there any emphasis on power efficiency and driving down overall system energy consumption?
Yeah, so I think definitely. So by being able to decouple the control plane in this manner, I think you can be a lot more intelligent, for example, about how compute and networking resources are used. So today, when you deploy your infrastructure, you kind of almost statically provision it, whether it's vertically integrated or even if it's virtualized today for the RAN. Most of the infrastructure, compute infrastructure, is provisioned statically. But if you have something like the rig, which has real-time visibility of where users are located in the network, how much traffic do they have, how much load are they imposing on the network, you can imagine one XApp being able to kind of program the underlying Kubernetes layer to figure out how much compute, networking, storage to allocate to different base stations based on the actual dynamic traffic demand at that time. So you can achieve much better statistical multiplexing efficiencies, lower power consumption, and much better operational efficiencies with capabilities like that.
Then, Sachin, I'd like to maybe switch our conversation over to the core network. In the last session, Vish from Dell Technologies talked to us a good deal about the benefits that operators can see by moving over to a sort of hybrid cloud operating model and the flexibility that can give them. I know last year VMware brought to market a 5G telco cloud platform that it's really a holistic environment to build, manage, and run containerized workloads. And this is for private clouds, telco clouds, edge, public cloud, all of it. So maybe you could talk to us a little bit about how those tools really set the stage for automated multi-domain network slicing, and then the monetization opportunities that kind of follow from that ability.
Definitely. So VMware introduced what's called the Telco Cloud Platform, and it has two critical components, right? So one is the infrastructure layer, which is both for the virtualization as well as the container layers. And it's a consistent infrastructure layer, whether it's core, edge, radio access network, or in the enterprise. So someone who is building an application, whether it's a VNF or a CNF, does not have to worry about what domain it's landing on, because it's the VMware cloud infrastructure is going to offer a consistent abstraction layer. So that greatly simplifies placement and allows mobility of workloads across these different domains. The other critical piece is telco cloud automation, which actually automates the placement, the routing, the stitching, the lifecycle management of workloads across all these domains. So imagine you're a telco operator, you want to introduce a new service, and that service needs to spin up some functions across all of these different domains. And you need to go place them, you need to go configure the underlying cloud to make sure that they have the appropriate resources, that they're stitched together correctly, and that they're monitored and made sure that their lifecycle is managed appropriately. So this is all completely automated out of telco cloud automation. And essentially, as we evolve to network slicing and you want to slice the network, including the cloud infrastructure for multiple different applications, it really is kind of makes the cloud and VMware's kind of main value proposition shine out, which is multi-tenancy, right? So you can actually deploy multiple competing things on the same infrastructure and make sure there's good isolation, and you can automate the bring up and deployment of such services. So really a big building block to enabling network slicing at scale, which is going to be the vehicle for monetization for a lot of telco operators.
Excellent. And Sachin, we started our conversation, you gave us sort of a state of play as it relates to network automation as it is today in carrier networks. But let's engage in a little speculation. If you look ahead maybe 2, 3, even 5 years, Where do you think the industry will be as we incrementally work towards this long-term vision of getting to true zero touch? I mean, when can the carriers in the audience feel comfortable taking their hands off the wheel, so to speak?
Yeah, so I used to joke, and I think this has been used in the industry before too. So SDN was software-defined network, but someone still had to write the software, right? And that was all humans, basically. And I think what this vision is trying to get towards is a new form of SDN, which is a self-driving network, right? So can I, like a self-driving car, have a network that runs itself? So it's a pun on SDN, but it's going to take a while to get there. And so really fundamentally where we would like to go is for a lot of the closed loop processes, right? So you want to be able to deploy something, monitor it, see if it's working as expected. So have intent from the operator or from the customer, and then be able to close the loop back into the infrastructure to make sure you're delivering on that intent, right? So really that automated closed loop, that's the end goal that we all want to get to. I'm really encouraged by what has happened over the last 2 years, right? So, and kind of to dig into detail of why. One is the adoption of Kubernetes and cloud native technologies means that the telco world is now able to exploit a lot of the open source and other software tools that are being built for the cloud, right? So whether it's for visualization, whether it's for AI, whether it's for telemetry and monitoring, whether it's for data processing, all of these are now a little bit easier to integrate, put it together, and bring it to the telco context. So I think we are now setting the stage for a lot of these things to be accessible, programmable, and a lot of data to be available for processing. And I think the next 2 years are going to see a flowering of AI tools being applied to solve a lot of these problems. And so I think we are at that transition point where really for the first time AI will begin to get applied. I think so far we've talked about it, but it doesn't really happen in practice. And I think that's going to happen over the next 2 years.
Self-driving networks. I think earlier we heard from Tarek that he looks forward to level 4 network autonomy. So it seems like we have a shared vision and a shared analogy here. So
Yes.
Sachin, I really appreciate you taking the time to engage with our audience and to have this conversation with me today.
Thank you, Sean. It was my pleasure.
And for everybody that's on the stream, I'd encourage you to go over to the roundtable sessions that are going on right now. And Sachin, thank you again.
Thank you.